Hi everyone. Now we're going to discuss variations, and of course we have four types of variations. We're going to deal with direct variation and inverse variation first. For direct variation, we have here there is direct variation whenever a situation produces pairs of numbers in which the ratio is constant. For two quantities x and y, an increase in x causes an increase in y, or vice versa. The statements y varies directly as x, y is directly proportional to x, and y is proportional to x may be translated mathematically as y equals kx, where k is the constant of variation. Now you can get the idea, for example, here looking at this statement, y varies directly as x, you just copy y first and translating this one, then varies means equals k. And then directly, it means to multiply. So you're going to multiply k to x. So you have here y equals kx, and don't forget that k is the constant of variation. Let's go with inverse variation. Inverse variation occurs whenever a situation produces pairs of numbers whose product is constant. For two quantities x and y, an increase in x causes a decrease in y, or vice versa. We can say that y varies inversely as x. xy equals k, or y equals k over x, where k is the constant of variation. In inverse variation, when you translate this one, you just copy y, and then again varies means equals k, and then inversely means divide. So you're going to use fraction bar here after k. So put a fraction bar as x and then put x in the denominator. So now we have discussed direct variation and inverse variation. Let's try to answer some problem related to them. So let's start with the first problem about direct variation. Given that y varies directly with x and y equals 40 when x equals 5, find x when y equals 24. So the step here is to translate first. So let's have our translation. So here, given that y varies directly as x can be translated as y equals kx. Again, right? The first unknown or the first variable followed by varies means equals k, and then, right, the last variable which is x. Next step is to look for the constant of variation or decay. To look for the constant of variation, first look at the second statement here. We have here a pair of number which is stated as y equals 40 when x equals 5. In that case, we can substitute those values to our translation. So we can have here 40 equals k, and then x is 5. Then solving for k, we're going to have here dividing both sides by 5. So the value of k is 8. So this is your constant of variation. Next is to look for the equation. To formulate the equation, all you have to do is to substitute your constant of variation to your mathematical translation, which is y equals kx. So just change k here. You'll get the equation as y equals, change k to 8, so 8, and then copy x. So we have our equation as y equals 8x. And then we have your equation in our problem. Find x when y is 24. So again, just substitute the values of y on our equation and you'll be able to solve for x. And let's proceed with that step. So change y to 24 equals 8x. Then solving for x, we'll get our value dividing both sides by 8. This will give you 3. X equals 3. Now you have now solved for the unknown in our problem regarding direct variation. Now let's go with inverse variation. If R varies inversely as S and R equals 6 when S equals 5, find R when S equals 45. So again, start first with the translation. So translate first your statement. R varies inversely as S. So we have here R varies means equals K, and inversely means you need to divide K by S. Now we have our translation or our mathematical translation. Next is to solve for the constant of variation. So next is to look for the pair of values that is given on our statement, which is R equals 6 when S is equal to 5. So again, substitute the values. R becomes 6 equals K over and S is 5. Next, solving for K, multiply both sides by 5, of course. So we can cancel out this 5 on our denominator. Giving us 30 equals K, or by symmetric property, K equals 30. And that is now your constant of variation. Then, look for the equation. To solve for the equation, again, just substitute the obtained value of K to our translated mathematical equation. So we're going to have here R equals, and then substitute K, which is 30 over S. Last one, find R when S equals 45. So again, substitute 45 on the variable S to solve for the value of R. So R equals 30 over, again, change S to 45. So R is equals to, let's simplify this one, and this will give us 2/3. And now we have solved for the value of R.